In the last experiment of the learning section in Unit 10, we started our world with mostly mean players and just a few mirror players. Running this several times, we find the following. Sometimes mirror players end up dominating the world. But sometimes, by chance, the mean players instead win out. In Program 3 for this unit, we're going to change the conditions slightly to see if it makes a difference. Rather than having each encounter be chosen at random between all players, we'll restrict encounters only to players who are near each other, neighbors. To do this, we'll be modifying this function, doGeneration, which is responsible for choosing the players for each encounter. Right now, 2 are chosen at random from the population. We'll instead be choosing pairs of indices and making sure that the indices are not too far apart. Let's start by getting a list of the possible indices. Here's our population. Here's how many items are in the population. That's the number of players. In our case, it's 18. And if we apply the range function to, say, the number 18, we get the numbers from 0 to 17, which are the possible indices. But remember that range does not quite return a list. Instead, it returns something that can be used to generate a list. We'd like an actual list, so we'll apply the list function. Now, when we choose, we won't choose 2 players from the population, but rather 2 possible indices. And we'll associate that using multiple assignment with these names, index 1 and index 2. Then, when we have our encounter, it will be between the player, I should say, at index 1 and the one at index 2. The only problem is that as things stand, the indices might be any 2. We'd like 2 that are close together. So we'll embed this statement within a while that keeps going while there's a problem. Here's index 1. Here's how far it is from index 2. This is the difference. We don't want the difference to be bigger than 3. The difference might come out negative, so we apply absolute value to make sure it's positive. And if this number is bigger than 3, we have a problem and need to choose our indices again. So here we keep choosing indices until we have 2 that are not more than 3 apart. To get things started, though, we need something that will allow us to choose the indices at least one time. Let's set index 1 and index 2 at 0 and 100 to start. The first time they'll certainly be more than 3 apart. Thereafter, we'll keep choosing randomly until we have 2 that are not more than 3 apart, that is, 2 that are neighbors. Now we're ready to test. Here's our first experiment. The mirror players win. A second, and the mirror players win again. A third. In fact, when players mostly encounter neighbors, it takes only a very few mirror players to dominate. As a last experiment, let's start with just 2 mirror players and see what happens. Notice that if we mostly encounter neighbors, mirror players almost certainly win.